Hello, everyone, and welcome back to another episode in the Introduction to Java series. In the last episode, we talked about if statements and conditional operators. In this episode, we're going to be doing a few exercises regarding the if statements and logic operators, as well as taking an introductory step into the next topic, which is loops. So, without further ado, please make sure you subscribe to the channel, notifications, all that type of stuff. Tell your friends to watch it if you are going to learn Java. And yeah, let's just get started right away. So we have this problem on the website codingbat.com. I strongly recommend you guys go to this site if you want to get good practice problems for Java or Python. So when squirrels get together for a party, they like to have cigars. A squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it is with a weekend. In that case, there's no upper bound. Return true if the party with the given values is successful, otherwise return false. So here's how this is going to work. We have to first visualize how we're going to be creating these branches of logic statement. So first, we have to know if it's a squirrel party. Now, it's a squirrel party if the number of cigars is between 40 and 60, unless it's on a weekend. Then in that case, there's no upper limit. So in this problem, we have two cases. We first have to make sure that the number of cigars is between 40 and 60. And we also have to check to see if it is a weekend or not. By that, I mean we have to see if is weekend is true or if is weekend is false. Then based off of that comparison, we then have to determine if there's a sufficient number of cigars to host a party. So, given what I just said, I recommend you guys to try and solve the problem on your own. Okay, so now that you've done that, the first thing that we have to do is determine if it's a weekend or not. So we do that by simply stating if is weekend. Now, keep in mind, if is weekend is the same thing as if is weekend equals true. They're checking the same thing. It's just that this is a lot shorter. Also, keep in mind that bang is weekend is basically the same thing as is weekend equals false. In programming, the exclamation mark is the bang operator. We call it bang, like this is bang. Okay. So if it is a weekend, then there is no upper bound on the number of cigars. So now we have to check to make sure if we have enough cigars to host a squirrel party. So simply, we're just going to say if cigars is greater than or equal to 40, we will return true. Now, the reason why we're returning true is because you have to remember we're coding a method. And in this method, the return type is Boolean. So that means we can only return true or false. Else, we're going to say return false. So we have this first condition down. But what if it's not the weekend? What if it's a weekday and we have to limit the range? Then we will go ahead and say else. Now, keep in mind, this else statement corresponds to this if statement. The else statement over here corresponds to the if statement over here. So if it's not the weekend, then we'll go ahead and say else if cigars is greater than equals 40 and cigars is less than or equals 60, we're going to return true. Otherwise, we will return false. So let's give a breakdown of this code. We're first checking to see if it's the weekend. If it's the weekend, we do this set of instructions. If it's not the weekend, we do this set of instructions. Assuming it is the weekend, we have to then determine if the number of cigars is greater than or equal to 40. If it is, then we return true. Otherwise, we return false. Then we have to determine to see if the cigars fit in the range between 40 and 60, if it's not the weekend. Then we have to return true, otherwise return false. And this should work. And as you can see, it works correctly. So you can also see their solution. So they did a shortcut, but it might not make as much sense as if you just did this. So by writing your code out like this, as opposed to doing it like this, you can clearly see what branches of the if statement are being activated and where you're going to return a statement. Okay, so that's amazing. Now, let's go to the next problem. So we will do date. I don't know, say caught speeding. So I want you to go ahead and try this on your own. Feel free to pause the video if you have to. Okay, so now that you've tried this on your own, let's go ahead and read the problem. Caught speeding. You are driving a little too fast, and a police officer stops you. Write code to compute the result encoded as an int value. 0 equals no ticket, 1 equals small ticket, 2 equals big ticket. If speed is 60 or over, result is 0. If speed is between 61 and 80 inclusive, result is 1. If speed is 81 or more, result is 2. Unless it's your birthday, then you can speed. Then on that day, your speed can be 5 higher in all cases. Okay, so this seems a little bit confusing. First of all, there are 3 possible tickets. Then you have to count for the fact whether it's your birthday or not. So we always want to work from in my opinion, you want to start off in your mind thinking what's the most specific case and then branch upwards from there. So in this case, the most specific cases would be whether you got a ticket or not. Now, what determines whether you got a ticket? The speed at which you drive. What determines the speed at which you drive? Whether it was your birthday or not, because your birthday can change the maximum speeds. So, for example, your speed will be 5 higher, can be 5 higher in all cases. So, 60 or more result is 0, 65 or more result is 0, and then so forth. So, we first have to determine if it's your birthday or not. Then we have to determine what speeds we have to use, and then we have to use those speeds to determine what ticket you get. So, based on our logic from going most specific to the grand scheme, we can now go ahead and write this method. So first, we're going to determine if it's our birthday. So let's say if is birthday. And remember, this is the same thing as saying if is birthday equals true. So once we say this, let's go ahead and actually type else. So we have our framework down. We're first checking to see if it's the birthday. Otherwise, we'll do something else. So now that we know it is the birthday, and this assumes all the code you write over here, all the code you write over here assumes this condition is true. So if it is your birthday, then let's go ahead and do something. So we first have to determine if your speed is greater than 81 or more. Now, you might be thinking to yourself, why don't we just determine if it's greater than 60 or more? Let me explain. So, when writing this type of code, you wanted to, if you say if speed is, I don't know, greater than or equal to 60 or less, result is 0. So if speed is equal to 60, 0. Actually, this could work. Okay, so you can start with this. If speed is less than or equal to 60, return 0. What this is basically going to do is that it's going to check the speed variable and make sure it's under 60. And then if that's the case, then it'll return 0. What if it's over 60 though? Well, if it's between 61 and 80 inclusive, the result is 1. Also, 1 sec. And it's your birthday, so I have to do 65. Okay, now that makes sense. So, sorry for the confusion. Let me recap. Basically, we're checking to see if it's the birthday, and if it's true, then we have to set the speed. So instead of 60, it'll be 65, and then we return 0. Now we have another condition. So instead of saying else, we do else if speed is less than or equal to 85, and speed is greater than or equal to 66, we'll go ahead and return 1. Otherwise, we know that it's greater than 85, so we return 2. Else, return 2. Now, Let's go ahead and copy the same lines of code here. Paste them inside this else statement and just lower the speed by 5. And voila, this should work. So this is an example of caught speeding. Okay, so you guys can continue to do more problems here. One thing I want to note is that in caught speeding, we use the ampersand, which means and, or if in that case you want to use or, you can go ahead and use the 2 bars. That's all I wanted to note. Okay, now we will be talking about loops. So let's look at this line of code. Suppose we want to say this, I don't know. Suppose we have these lines of code and we run it. It'll take a while, but we'll get there. So it prints hello world a lot, right? It prints it all these times. But why do we have to print 20 different print statements? Is there a way we can just do this quicker? Is there a way we can loop the print statement so we can keep on printing until we hit a certain count? That's what loops are for. So I'm going to go ahead and delete all these lines of code. So now you can see why loops are helpful. Loops are basically used to avoid repetition. So as you can see here, we are repeating all these lines of code when we can simply loop one statement into doing it over and over and over again. So now let's go ahead and use a loop. So what types of loops do we use? Well, in Java, you have 3 different types of loops. You have a for loop, you have a while loop, and you have a do while loop. In this episode, we're just going to be talking about for loops, but I'll go ahead and quickly explain the 3. For loops. The thing with for loops is that you already know how many times you're going to be running the loop. So if you want to run a loop 20 times, if you want to do something 20 times, you use a for loop. Now with while loops, you're basically repeating the thing on the condition or the code on and on again until you find something that you're looking for and you break out of the while loop. And then you have do while loops, which checks an initial condition and then goes into the while loop. So we're just going to be focusing on a for loop, which is repeating a certain amount of code X times. So one that makes the most intuitive sense. And the others make sense, but we'll get there. So how do we write a for loop? Well, if we want to say this line of code over 20 times, we simply have to say the following syntax. And I'll explain it in just a second. So for So as you can see here, we have the syntax for a basic for loop. Now, this might seem very, very cryptic to you guys because you're like, okay, what is line 5 all about? You have the word for, you have a bunch of stuff separated by semicolons, then you have the braces and you have your code. But let me go ahead and run it to you to prove to you guys that I'm not actually lying when I say this thing will repeat 20 times. As you can see, executed the thing 20 times in grand total of 4 lines of code. So it's quite efficient. So how does it work? So the first thing we have is to declare what type of loop we have. In Java, all the words highlighted in blue are called reserved words, which means like you can't use them to declare as variable names, things like that, because they have a key function. In this case, we're initializing a for loop. So we're doing an item for 20 times. We're doing it for so many times. That's basically why we call it for loop. So this first thing over here, all this is doing is it's establishing a counter. So you want your counter to start at 0 and go up to 20. So you're going to be counting 1, 2, 3, 4, 5, 6. Actually, this prints 21. So I mean, it's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so forth. This basically acts as your starting point for the counter. One thing to note, this will run 21 times because we're starting at 0 and going to 20. So to run 20 times, I'm going to go ahead and say less than 20. Okay, that's just a small fix. But anyways, okay, so this acts as your counting starting position. Now, if I is 0, you want to keep on doing this statement of code until the variable I becomes 20. Once it's 20, you stop doing the statement because your counter is you've counted all the way up till the number you want to. Think of it like hide and seek, okay? You have to count for 20 seconds before you can start to find someone. That's essentially what this entire thing does, okay? You start at 0, and you're doing this statement until the variable I is no longer less than 20, and you're incrementing by 1. So that means after every time you execute the statement, the value of the variable I increases by 1. So on the first iteration, I is 0. So you print this line out, and the value of I is 0. So to prove it to you, let me go ahead and say system.out.print I. Let me go ahead and, okay, this will be print. Let's go ahead and run this code. So as you can see here, I printed the value of I all on the sides of over here. So on the first iteration, the value of I is 0. Then after it goes through, it checks to see, okay, is I less than 20? It is. So we're going to increment I by 1. Then it runs it again. Then it checks, okay, is 1 less than 20? It is. So we'll increment I by 1. So now it's 2. And then it runs it again, and so forth, until we get to the last one, 19. When it's like, okay, it's 19 less than 20? It is. So we're going to increment it. So it becomes 20. And it's still going to run this. But when the value of I gets run again, then it's going to break because, 20 is not less than 20. So that's what happens. So you'll keep on going until the value until this condition is false. That's how the for loop works, if that makes sense to you guys. Okay, so one last thing that I wanted to do is I wanted to combine for loops and if statements. So a challenge I have for you guys is to try and print every even number from 1 to 100. So I'll go ahead and give you guys the basic framework. Go ahead and try to print every even number from 1 to 100. And this is my hint so far. Start off with this and then edit the for loop. So pause the video now and try, and we'll come back and discuss it. Okay, so now that you're back, let's go ahead and try this on our own. So if we just run this, give it a sec. Oh, let me do println to make it more legible. Okay, let me try it again. We're just going to print 1 to 100, but we want every even number. So there are 2 ways you can do this. First, instead of incrementing the value I by 1, you can increment it by I equals I plus 2. So, but I want you to go ahead and tell me if this will be even or if it will be odd. What is your guess? It's odd. Now, why is it odd? We're incrementing by 2. The reason is because we're starting I from 1. In order for this to work, we have to start I from 0. Does that make sense? So if we run this, now we should get every even number from 0 to 100. So yeah, that's how it should work. Okay, cool. So what if we wanted to do every even number from 0 to 100, but we want to increment by 1? How would we do this? Well, we'd use an if statement. The way we do this is that we just basically say if I modulus 2 equals 0, Then we're going to print it. And this works. Now, why does this work? Because remember, modulus checks for a remainder. So if a number is divisible by 2, there should be a remainder of 0. So we're basically just checking to see, okay, if this number is even, then we're going to print it. And that's the basic logic behind for loops. Now, I want you guys to try and print this in a descending order from 1 to 100. But instead, it'll be 100, 99, 98. Go ahead and try that out on your own, and we'll talk about it in the next episode. But as always, it's been your boy, and we'll see you in the next one. And the next one, we'll talk a little bit more about loops, as well as dive into while loops. So thank you so much for following the series. If you liked it, once again, please subscribe to my channel and give this video to all your friends and family if they are interested in learning Java. And yeah, that's it.